Hi kids, we'll be looking into the another question. Two ideal inductors, each of inductance L, are connected in series and a capacitor of capacitance C is connected in parallel to one of the inductors. This combination is connected across a battery of EMF E through a switch. Initially the switch was open for a long time and the capacitor was uncharged. How will the voltage on the capacitor vary with time after switch is closed? This is the answer. So what is the thing we'll be doing? We'll be writing loop equation obviously. So when it is closed, at any moment when this current is I, that current will be split into two parts, x plus y, and I can say I equals to x plus y, KCL at this point. Now this will be getting charged. So positive charge, negative charge, and I am assuming currents are increasing. For writing math equation easily, math will take care of anything. So higher potential, lower potential, higher, lower, higher, lower. Now I will be writing loop equation. I need to find something about this, so I will be writing the loop equation this way. If I write the loop equation that way, I will be getting plus E minus L di by dt, plus E minus L di by dt minus Q by C equals to 0, plus E minus L di by dt minus Q by C equals to 0. But these two are not exactly related. Q, x is nothing but the rate at which Q is getting accumulated. X is dq by dt. Now apart from that, these two are parallel. So this potential difference equals to this potential difference, that is Q by C equals to L di by dt. This current is y, so dy by dt, right? So this is the loop equation. This is parallel condition, and this is KCL, and this is current equals to rate of accumulation of charge. Now I have got four basic equations. I need to modify it, and I need to get something about this. So I need to get the equation in terms of Q and X. That will be better for me. So this is I dash. I want to eliminate this, and I need to make it in form of X. I dash I need to eliminate, so I dash I will be finding I dash is x dash plus y dash, y dash I can find from here, that's okay. X dash I need to find, so I will be differentiating it, I will be getting x dash. So y dash I will be substituting from here, x dash I will be substituting from here, I will be getting I dash is this much. Once I get I dash in terms of Q, I will be substituting it back. Instead of I dash I will be substituting it back, then I will be modifying the equation. This looks like familiar equation. Instead of Q double dash, I am writing it as Q minus CE by 2 whole double dash, because you know when you are taking differentiation of constant is going to be 0. When I write it this way, this looks like familiar equation. If this is some constant, this is double, if this is something, this is going to be double differentiation of that thing. So it looks like SHM form. X double dash equals to minus omega square x form. Then I know the general solution. The general solution is going to be that x thing equals to a sin omega t plus b cos omega t. If I differentiate it, I will be getting q dash equals to a omega cos omega t minus b omega cos omega t. This is sin omega t cos omega t. Now at t equals to 0, what was the charge on the capacitor? It was 0. And at t equals to 0, what is the rate at which the charge is getting accumulated, or the current in the capacitor? It is 0. At t equals to 0, this is going to be 0, and this is going to be b. This is going to be a omega, and this is going to be 0. From here b will be minus CE by 2, from here a will be 0. So I wrote the general solution, and I have two variables. I have taken two initial conditions and I solved for both a and b. Now when I substitute it back, when I substitute a and b back, I will be getting q minus CE by 2 equals to a is 0 and b is minus CE by 2 into cos omega t. From here I will be getting q equals to CE by 2 into 1 minus cos omega t. They asked what is the potential difference. Potential difference is q by c, that equals to e by 2 into 1 minus cos omega t. Cos omega t, where omega is how much? Root of 2 by LC. From here you can see omega is root of 2 by LC, right? Thank you.